Welcome to Ask and Learn.
So in this problem, we have a crate that's being pulled on the right side with a force of 1,000 newtons. And on the left side, it's being pushed with a force of 800 newtons at an angle of 30 degrees. And you want to find the distance, s, that this crate travels when the velocity is 6 meters per second, which we'll call v2. And we're also given coefficient of kinetic friction, 0.2, and the mass of this crate at 100 kilograms. So because we're dealing with forces and we want to calculate the distance traveled, we can use the equation for work, which is just force times distance. But we also are given a velocity. And because of that, we know that there's a kinetic energy involved because kinetic energy deals with movement. So that means we can combine those two and use the work energy principle, which is given as the initial kinetic energy of the object plus the work being done on the object is equal to its final kinetic energy. But because the object is initially at rest, initial kinetic energy is 0 because the velocity is 0. So now we're just left with the work being done on the object is equal to its final kinetic energy. And we can expand this a little bit. So the work being done is the force, and this force is in the x direction because that's where the movement is at, times the distance traveled is equal to 1/2 m v2 squared. And we'll call this equation 1. So in order to solve s, we need to find the force in the x direction. So to do that, we use a free body diagram so that we can see all the forces on this crate and then find what they are in the x direction. So we have the weight pushing down on the crate, which is just mass times gravity. Then we have a force in the opposite direction, a normal force, Fn. And on the right side, we have that force, 1,000 newtons. And we're given a triangle here to make the calculations a little easier. This helps with the components. So we have this triangle of a hypotenuse of 5, bottom part 4, and the right side 3. So that means on the right side, the x direction is 1,000 times the x component. And looking at this triangle, we want to find the bottom part. So that means the x component is a ratio of 3/5. So it's 1,000 times 3/5. In the y direction, well, it's just the right side. So it'll be 1,000 times 4/5. Now on the left side, we have that force that's pushing the crate of 800 newtons. And then this has components. So we have the force pushing down of y. And then we have the x component, f of x. So from geometry, we know that taking the cosine of that triangle, we have f of x is equal to f times cosine 30. So it's 800 cosine 30. So then doing the sine will give us f of y is equal to 800 sine of 30. So now we can find the forces in the x direction. So looking back at the diagram, if we say going up and to the right is positive, then in the x direction we have, on the right side we have the 1,000 3/5, and then we have on the left side we have the f of x, And we also have the force due to friction, and that's always the opposite of the movement. And this is the kinetic friction. So again, in the x direction, we have from the right side, 800 cosine 30. That's from the left side, and from the right side, it's plus 1,000 3/5, and then we have the friction going the opposite direction, so it's minus, and then for friction, it's coefficient of kinetic friction times the normal force, F of n. So in order to complete this calculation, we need to find the normal force. And going back to the diagram, the normal force is in the y direction. So now let's find the forces in the y direction and then solve for F of n. So we have F of n is positive, plus from the right side, 1,000 times 4/5, minus from the left side, and it's negative because F of y is pointing down. We have minus 800 sine of 30. And since the weight is pointing down as well, that's minus mg. And we know mass is given and gravity is 9.8. This is equal to 0 since there's no movement in the y direction. So plugging into the calculator and solving for F of n, we get 580 newtons. And now we can plug this back in and find the forces in the x direction. So we have, again, 800 cosine 30 and 1,000 times 3/5 is 600, and then minus the coefficient kinetic friction, 0.2 times the normal force that we just found, 580. So the forces in the x direction is 1,176.82 newtons. Now finally we can plug this back in to our equation from the very beginning, equation 1. So we have this force we just found in the x direction times the distance traveled s is equal to 1/2 m is 100. V2 is given, which is 6, and that's squared. So plugging in those numbers and solving for s, we get for the distance traveled of this crate is 1.52 meters.